So what we're going to go over in this video is looking at some more R functions that'll help you with understanding how to graph. And then the next video will actually cover how to graph things in R. So let's start with some file functions, because getting files into R is one of the most important things you can do, because generally our data sets are not generated on the fly. They are created in another program or Qualtrics or SurveyMonkey, and then you want to use them to be analyzed in R. So a quick note, I'm using the Andy Field Discovering Statistics in R book to teach my course. And in part of chapter 3 and 4, he talks about packages, discovering statistics, using R, but that package is not a thing. So mostly I think it was just a way to put together many of the functions he talks about, but it's not actually a package that I can tell. So instead, we'll just do their own separate packages. So some important things that haven't been covered on some previous YouTube videos that I've uploaded or in class. So we're going to do file functions, so more functionality on how to import files. Some factor functions, so how can I make sure my data is listed as a factor, and that will really help you work with independent variables that are categorical, and rearranging functions, specifically the Reshape package, and learning how to melt and to cast data. So formatting data in different layouts. All right, so we've already talked about how to import data using the import function in RStudio, but the problem with that is it only works for CSV or sort of specific text delimited files. So what if you want to import, let's say, an SPSS file? Or what if you just aren't good at the working directory stuff? So there's another video that covers working directories sort of way too much. But what if you're just like, I don't get it, I don't understand it, I don't know why she keeps going on about working directories. What if you just want a very flexible solution? So going back to Studio real quick, the import option I'm talking about is here under Import Dataset. You have From Text File. And that is where it'll let you pick a file that you know is on your computer. So let me go to Notes here. And I could pick this chick flick data, for example, and import it as chick, and then click import. And what that does for me is it actually brings up the code down here, and it gives me the long path version. So it lists the entire path for that particular file, and then loads the file as a data frame. Okay. What if you don't have CSV? So you need to read in an SPSS file. So that's what we're going to cover. So there are two packages that work with files. There are actually more than two, but these are the two that I'm familiar with. Foreign and memisc. Lots of people like foreign, but I don't think it's actually been updated in quite some time. And it does work, but often will give you an error. And every once in a while it'll do something really funny. And you won't notice until you try to do something with the data set that it's kind of funny. memisc seems to work great. I really like it. It just requires an extra step. So the pro to foreign is that it's one step, but it often will give you errors. The pro to memisc is that it doesn't give you errors, but it's 2 steps. So pick whichever one you like better. And so the first thing you want to do is make sure those packages are installed. I have them installed on my computer already, but if you don't, remember you can do install.packages. This is going to be foreign for the foreign package, and install.packages is going to be memisc for the memisc package. Since I already have those installed, first thing I'm going to do is load the library. Okay, that's always important. So let's go to library and be sure foreign is turned on. And then library and be sure memisc is turned on. Now, I'm going to show you both of these today, but really pick one. Okay, so pick your favorite one and use that one. Let's also make this just a little bit bigger so it's easier to see. There we go. Okay. So I've got memisc and foreign loaded. So let's work with them. So be sure they're installed and be sure to load them. So you will do the thing where you are like, it's installed, why isn't this working? And you forgot to load it. So be sure you always load the library when you get started importing packages, importing data sets. The other thing we're going to talk about is file.choose. So file.choose allows you to pick the file from your computer. It essentially tells R to open a window to find the file. So instead of typing the file path directly, you just type file.choose. So instead of having to type all of this stuff out, you can just use the file.choose function, and it will pop up a window that lets you pick the file you're interested in. I like that a lot, and so let's try it, and then I'll tell you the pros and cons about this. So let's let's do some data here. So I'm going to use the read.csv function. So I'm basically going to copy what I did here, and I'm going to say check is equal to read.csv, because I know it's a CSV file, and I'm going to type file.choose. Studio automatically gives me the open and close parentheses, make sure they stay. And then I'm going to turn on the header equals true. That is the default, but sometimes it's a little grumpy, so be sure you use that. So when I run this command, what happens is I get a window that pops up, and it lets me go through and find the file I'm looking for. So it allows me to look at all 7 million files within files here. I can pick the chick flick data, and then now it's opened that same data set for me. So the good thing is that's pretty easy. And it is perfectly it's an acceptable option. The bad thing is, like, anytime you run your data, you will have to select that file every single time. The other issue is you don't see the code that it ran in the background. So when I did that import function, it showed me the code that I had run. So I could copy that code and put it up here, and now I don't have to think about it. So unless I move that file, I simply just have to rerun that line. But here, I have to remember what file it is that I picked every single time. So if you're going to use file.choose, in the sake of sanity, oops. So make yourself a note on which file you're using. If you're anything like our research lab, we'll have 5 or 6 data sets that we've kind of, oh, this is time 1, this is time 2, or this is the fixed data set, or fixed this data set with this date. And it can get very confusing on which data you should use. And if you're using file.choose, it's not obvious which one you picked. So if you're trying to recreate your analysis, let's say when you get a review back on a paper, be sure you've made a note to yourself, this is the file we're using for this particular analysis. So I'm really big on making sure you can do things again later in the same way. So that's the bad thing about file.choose. So the second thing we're going to cover is read.SPSS. So let me go over here. So this is how I do read.csv. Let's say instead I want to read in an SPSS file. So read.SPSS, okay, that's part of the foreign library. And then what you want to do is type the file name. Well, I could do file.choose here for the file name. Okay. Use value labels, defaults to true. To.DataFrame is the important one. So to.DataFrame, that defaults to false. You definitely want that to be true, because most of the things we're going to do involve using them in DataFrame format and not matrix format or a data set format. On the rest of that, I just leave alone because it mostly works fine. So if I run this, it'll force me to pick a file. So I would go through and find that file. I really should set my working directory so I don't have to go through this every single time. Here's my chick flick data. So here's the problem. It gave me a warning message. So it didn't like something about that. But warning messages aren't necessarily the end of the world. And you'll notice that it did import with the value labels. If I get a summary of that data set, you can see that it imported with the labels for each of the independent variables. It also imports with the attributes. So I use the attributes function. It actually imports the label column as well. So if you're used to SPSS, it imports not only the value labels, but the label column, which is really nice because now I have variable labels that I could use in another way. So it actually imports as kind of a data frame with some extra attributes on top of it. memisc does not do that. So that's a good thing about foreign, but sometimes foreign's just grumpy thing. And so if you're having trouble with foreign, what you can do is memisc instead. So the other way I could do that is actually put the file name in here. So I could type the file name out. And then these two work the exact same way. So this one is with file.choose, where I am telling it to pick the file. I want to pick the file manually, and this is with the actual dataset name. I prefer to do it this way, simply because I know what dataset I've used every single time, but file.choose is a really great option as well. My one word of warning, especially if you're on a Windows machine, Macs aren't as bad about doing this, is sometimes the window that you want to click on, the pop-up window that'll show you all the files, appears behind RStudio. And so if you run that line of code and sort of it looks like nothing happened, but there's a little stop icon, it'll appear right here next to the console, a little stop sign. What you want to do is just minimize RStudio, and it's usually right there in the background. So sometimes it pops up behind Studio, which is a bit problematic. Don't run it multiple times because it will open multiple windows, and then sometimes R will crash because it's just grumpy with you for doing 6 things at once. And so if you have the little stop icon right here, look for the window behind Studio. So kind of minimize, don't close, but minimize Studio, and it should be there in the background. Okay, so let's talk about memisc. So the way memisc works is a little bit trickier. So it's as data set SPSS system file. If you try to do it without both of those, it doesn't work very well. So let's type that out. Okay, so the first one's foreign. So it's as data set. Okay. So that's one function that imports it as a data set, which is a different type of object. Okay, it's not a data frame, it's a data set. I'll be able to show you a little bit of that difference here in a second. And then the code for memisc is SPSS system file. And then what you could do is file.choose. So we've got 3 functions all in one here. And then there's actually nothing else that you have to include. There are other options that you could include with SPSS system file, but you don't actually have to include them right away. This is sort of the quick and easiest version. So let me run that. All right, so let's go to a folder we know has a SPSS file. So what that did was it pulled it up as a formal class data set here. And if you'll notice, it actually pulls it up under values instead of under data. And so that is how you can tell that it imported correctly. And formal class data sets you can actually use, you just can't view them. Okay? And so it just treats them in a slightly different way. So let's look at a summary here. Okay. And so it looks like visually the same. But let's say you want to make some graphs of this data in ggplot. Well, it does not like data sets. It wants it to be in a data frame. So the bad part about memisc is that it doesn't really let you import it as a data frame first. I have tried changing this to data frame here, and it just doesn't work. So if you have a better solution, I would love to know. So instead, what you would do is just convert it to a data frame. So we're going to coerce that into a data frame. Right, which we would do by doing this. Okay. And then we type the same data set name. So I'm just taking that data set and converting it into a data frame. So you notice it moved up here to data. And then now it has all the same levels. So it actually looks the same as chick2, which was my foreign version. It just doesn't have all those attributes. I think they probably both work equally well, but if you're having trouble with foreign, try memisc instead. There are many Stack Overflows on this exact question, and there's something about it that in the newer versions of SPSS, it reads something incorrectly. I also could do here the exact file name. So I have that one here. So I could type in the exact file name here and hard code it. So that would be how you'd import. So if you're going to do foreign, just be warned, you are going to get a warning, usually. If you're going to do memisc, don't forget this line. Or when you go to make graphs, or do some of the data analyses, it won't run. All right, so I'm on a Mac using Yosemite, and it doesn't always play nice with Windows. We can agree to get along, and just every once in a while it does something funny. So what happens is sometimes when I create data sets for my students on Excel for Mac, when I move over and start importing it on Excel for Windows and importing it into Studio, it gives us some goofy symbols. So what do I do to fix the funky symbols? And what I can do is a couple of different ways. So let's say that my Chick 3 column here, I didn't want it to say gender. I wanted it to be something else. One simple way you can do it is actually create a new column. So I'm going to do Chick 3. I'm going to call it new column just to make it clear what I'm doing. That column doesn't exist, so let's create it. Is equal to Chick 3 $gender. And so you would cut and paste whatever the funky column name is and move it here. Okay, so if you got some weird symbols, you'll have to cut and paste them. And what that will do is create me a new column in this data set with the name I'm interested in. That's actually pretty easy, and that'll work fine if you're not doing a whole lot with the data. If you are then going to data screen the data and do some analyses, it's probably going to be confusing that you have multiple columns that are the same thing, and especially when you get into data screening. So you'll have an extra column, one more column than you should, because they're repeated with each other. And if you start to do correlations or Mahalanobis calculations, it'll be very unhappy with you that those columns are exactly the same. So while this is easy, I don't recommend it for things you know you're going to do big analyses on, because then you'll run into some more problems later. But that is the simple way. The other thing you can do is use the column names function. Column names will be your friend, because it'll allow you to change one column name or all of them. And so what I want to do is use call names. The name of the data set goes here. So Chick 3. And let's say I want to change the first column. So this is going to be a square bracket here and a 1, because I'm going to change column number 1. It doesn't quite let you do where you could just type in gender like this, like change this column name. That doesn't seem to work. And there are other ways to change column names. This just to me is one of the easier ones. So I want to create column names for this data set, but specifically only column 1. Then what I want to do is name it. So let's say I want to call it gender of part. Okay. So be sure that's in quotes because it is text. And so now I've changed that column name. So you'll notice up here, I've changed the column name. If you want to change all the column names, you just type in the name of the data set, no square brackets, and create yourself a vector of column names. So we're going to use the concatenate function. And be sure you have the same number of text pieces here as you do columns. So I have 4 columns, so I need 4 of them here. So I'm going to rename it gender, film, arousal, and extra column, just to rename them. So I have 4 names here and 4 columns here. And then that will change the names of the columns over here. Okay, so you can change one column or all of them. All right. So all of that is just some basic file functionality. So you should be able to import SPSS files, CSV files, and then import them by using the exact name of the file. If you want to do it that way and you're not totally getting it, go back and watch the video on file functions. Or you can import it using the file.choose option. So now let's get into factoring. So I'm going to start with some fake data here, just to show you. I know I've got a bunch of data sets loaded, but I'm going to start with my fake data. And this would be if you wanted to create something on the fly, or if you were trying to do an example for a YouTube video. So I'm going to say this variable is not factored. I'm just going to create some data. So the repeat function allows you to repeat numbers. So I'm going to repeat 1 through 3 50 times. So let me run that. Let me show you what not factored looks like. So it's literally 1, 2, 3, 1, 2, 3, 1, 2, 3, 50 times. Great. So I have 3 groups repeated 50 times. But now let's factor that. So let's create a factor variable, which is the way that these got imported from my CSV files because they have the labels in them already. So R does smart import. If your data that you're importing has text, it will try to import it as a factor. Okay, so that said, let's do the factor option. So the way the factor function works is the first thing you need to put in is the column name, so it should be a specific column. If this is within a data set, be sure you use the $ operator to pull that column out. What you then want to do is tell it how many levels are there. So levels should be 1, 2, 3, 4, or in this case 1, 2, 3, and then tell it what the labels are. So the number of levels here needs to match the number of labels. So let's try, and there should be one more closed parentheses here. So let's try that. So the factored version of this exact same column, we're going to use the factor option. And so it's the name of the column, so not factored. I'm going to do levels equals 1, 2, 3. Okay. Labels equals, and then give it labels. So I think I did Swiss, Beta, and Gouda. So what happens when I do this? Now I have a variable called factored. You'll see it's factor over here, the type. Or I could do class factored. Okay. So class type is a factor versus the class of the not factored variable is an integer. Okay. And that is switching it from basically having labels to not. So this is, we're treating this as a number or as a categorical variable. I can also create a table of my factor variable to prove to you, oops, sorry, not a table of that function, that it has those labels. So there's 50 people in each group. So the factor function is pretty easy. The main concern is to make sure that the number of levels here has the same number of labels out here. So it'll be very unhappy with you if you say there are 4 levels and don't give one of them a label. Okay. So be sure that the number of levels and the number of labels has the same number of items. Okay, so if there are 4 here, there should also be 4 here. The interesting thing is you can add a factor that no one is part of. So let's come up with one more cheese here, Munster. And so that ran. So let's look at a table here. So now I've added a condition that no one is in. Okay. If we were then going to add people, it would know, okay, these 4s are this group. Okay. That can be problematic if you have labels that have no cases when you start to run things like the memisc function. So imputing data, sometimes it gets unhappy with you if you have labels out there that have no cases. Just a warning. Alright, so there'll be more about this factor function and Relevel, which allows you to reorder the order of the factors in the ANOVA section. Relevel becomes important when you want to make your comparison group a different group. It also, R will code the factors in the order you give them, 1, 2, 3, 4, then it always displays it to you in alphabetical order. So if you want to, on a graph, show low, medium, high, you have to tell it to reorder those because alphabetically it would be high, low, medium. And so the factor function becomes important for graphs and Relevel becomes important for ANOVAs. So we'll cover this some more later in another video. So last but not least, let's talk about the Reshape package and what it will do for you. So be sure you've installed Reshape. I already have it on my computer. And this is Reshape 1. So I'm just going to load that library. So I'm going to first import the Gemini Cricket data set from the Andy Field book. So let's do cricket is equal to read.csv. And then I would want to say where the file is. Well, I'm actually going to do something here. I'm going to set my working directory. So I'm going to show you how I like to do things. So let's pick my working directory here. So I don't have to click through this 1,000 times. There we go. And then what I would do is copy it, stick it in my data set here, so I can run it again later. And then when I do that, if you come over here to files, it actually shows you what file folder you're looking at. So now I can type read.csv and tell it exactly what the data set name is. So it's chapter 4, Jiminy Cricket. .csv, so be sure you include the extension, and then header equals true. So now that let me import my data set here as Cricket without having to do file.choose, so I can remember later what data set it is. This is explained in another video, but this allowed me to say, look in this folder for this file. And I like separating them out in case I move the data sets, because then I don't have to change every single read.csv line. I just change one working directory line. So that's the advantage to doing it that way. All right, so that being said, let me get into reshaping data. So if you look at a summary of this data set, or if you just view the data set, it's in what we would call wide format. So wide format is where each participant is their own unique snowflake, is the way I've always described this to people, and each person gets their own row. And so what that means is that each participant's repeated measures data is coded as a separate column. Okay. So each participant has their own row, and each repeated component is its own column. If you've been working in SPSS for a long time, you're familiar with this, because if you try to stack the data in what's called long format, it doesn't run the analyses correctly, and like you can't run a repeated measures anything unless it's in wide format. So lots of people work in wide format. It makes sense because there's one person per row. So let me introduce you to long format, which also makes sense if you kind of think about the way analyses work. So long format is where each row is its own DV measurement. So the participants are repeated across rows. So let me give you an example. I work with some people who do EMA, Ecological Momentary Assessment, where they take participant data 5 times a day across 5 days. So for each dependent variable, there's 25 columns, which can get very tedious in wide format. What we end up doing on this data is running it as a multi-level model, which requires it be in long format. So instead of having day 1, time 1, day 1, time 2 in wide format, we can stack the data and do long format. So let me do this in Excel just to kind of give you a visual. So this would be participant 1, this would be day 1, time 1, and then we have day 2, day 1, time 2, day 1, time 3, etc. Okay. So this would be wide format. Now long format would look this way. So I'd have participant 1, I'd have day 1, time 1, DV score. Okay. And then I'd have participant 1 again, then I have day 1, time 2, DV score. Okay. And then we keep going. So it changes it basically from columns to rows. You get the idea here. And so what will happen is this is a coded column for the day that we did it, this is a coded column for the time that they were taking it, and this is the actual DV value. Okay, so they would be taking body assessment measures. Now, the nice thing about doing it in this format is what always I feel like confuses students when I'm teaching them repeated measures in SPSS is normally you think about between subjects, that's where everybody starts, is like I have a column for the IV and a column for the DV, and that makes sense. In repeated measures data in wide format, I have column for the IV, and it's the same column as the DV. So I always talk about the labels for the columns are the IV levels or conditions in repeated measures, and the actual numbers of the columns are the DV. But, you've spent all this time in between subjects knowing one column for IV, one column for DV. And you get to repeated measures, you're like, forget all that crap. Now it's one column for the IV and the DV at the same time. And that's just the way that the SPSS has decided to code those, the way the analysis runs. But in R, it makes much more sense. Now I have one column for the IV, or here are two columns for the IV and one column for the DV. So that in long format is always true. There are IV columns and there are DV columns. It's just that sometimes the DV column is repeated because it's a repeated measures design. Once you get to working with long format, it actually makes a lot more sense if you can let go of your SPSS holdouts. So if you've never learned wide format, awesome, don't do it. It does have its advantages, but generally long format is better for repeated measures data. So what if I have wide format because that's how Qualtrics gives it to me, or SurveyMonkey, or I'm importing from somebody from SPSS? We can switch from wide to long. It's called the melt function, so we're melting the data. Going from long to wide is a little harder. It's cast. You would think that these would just be sort of inverses of each other, but they're actually pretty different. I don't like cast so much because I find it a little confusing, but I'll show you both, and generally you're mostly going to be melting data. So the way melt works is that you first tell it the name of the data frame, and then you tell it the ID variables. These are variables you don't want to change. Okay, so participant numbers, between subjects, columns, demographic variables. So these are like, leave these variables alone. These will get repeated across columns so that it still is tagged as participant 1. Okay. It's labeled ID. It doesn't necessarily have to have a specific ID column. And so if your data is completely repeated, you actually won't have this code right here. Comma, the measured column. So measured column you have to have because that's the point of melt. And it will let you combine all the variables into one column. So it's like, this is basically all the repeated measures columns. So these are all the column names that you want to be squished into one. All right, so let's try that. So I have my Jiminy Cricket data here, and I want to make it a long data set. So let's go long cricket. Okay. So melt is the function. So first thing is the data set name, which is cricket at the moment, because that's the data set I'm working with. So this has to be in wide format. My ID variables, things I don't want to change. The first one's called ID, so this name here. And if you aren't sure, if you have a lot of column names, you can use the names function to look at the column names, and that'll give them to you in numerical order, or the ls function, which will give you all the column names in alphabetical order, which happens to be the same in this data set, but often not. Oh no, okay, here, it switched these two. So I got ID and then strategy, so I can actually just cut and paste it from down here if you want to be really lazy. Comma, okay, so my ID variables have to be concatenated together. So that means just make these two into a little mini vector. I want both of those to stay the same. My measured variables, we're going to also concatenate, and I want to use success pre and success post here. So it's got 3 parts. Data set name, variables I don't want to change, variables I do want to change. If you're going to cut and paste, don't forget you got to put a comma in there, or they'll be unhappy with you. So what you notice I did is I put each piece on a separate line. That's just visually to help see what's going on. You can totally work R this way to organize the looks of your syntax file. Just make sure each line ends with something that R knows that another line is coming. So it's got a comma here, meaning more to come. So I'm going to keep going. I can run each line individually, and it'll be fine because R understood that I wanted something else on the next line, or you can highlight all 3 and run them all at once. Okay. All right, so let's see what that did. So let's look at a summary. Oops. Okay. Now you'll notice my ID column and my strategy column haven't changed. I have this new column called variable, which is not super useful in naming, but that is the name of the variable it came from. So I had success pre and success post before, so it just added them as value labels. So that's a factor column. And then value. Value is your DV column. Okay, so let's look at it here. So I have those two variables. Well, let me make it bigger here. My ID, my strategy haven't changed. I have success pre and post, and then my value column. So I could sort this out. Hopefully it'll let me expand the column here, but it's being grumpy. Where I have success pre and post. If you sort by ID, you'll see I have one line for each person. Okay, so I've got, I'm sorry, one line for each DV. JK, that was wide format. I have one pre and one post for each person. So this is their pre-score and their post-score for participant 1. So basically took that success post column and tacked it on the bottom. Now, if you, gracious, computer is freaking out today. If you don't like the naming of this data set because variable and value are not the most mnemonic names, remember you can change the names of them. So I should say column names for my long cricket data set are, let's go, we got ID and strategy we want to leave alone. Now let's call this time, because that's what happened. We've measured it across time, and success score. And that makes a lot more sense. Okay, so now I have my IV column, what time did I measure them, and my DV column, what success score did they make. All right, so that's MELD for you. If you want to go the other way for some reason, you want to, let's go through all this right here. You want to go from long to wide format. That function is cast. Cast is a little tricky, and this is described very poorly here because I just don't have a good way to explain it. So I'm going to try to explain this a little better just by giving you the example. So if I want to go back to wide cricket, we're going to use cast. And so cast, the first thing you list is the data set name. So long cricket. So this has to be in long format. Okay, go away. And so then what I want to do is list all of my ID variables. So these are all the variables that you have here. Okay. But you don't do it like this because that would make too much sense. So what we're going to do is do ID plus strategy. Okay. And so we're just adding them together. There's no quotes on these because they're column names. And so you're just adding them together. If you have more of them, just keep adding pluses. Okay. And so those are the only two. Now I'm going to do the tilde and do another line here. And this is where all my measured variables are going to go. Okay. So the long DV name. So this is the actual one DV column. So at the moment it's called success score. Okay, because that's my DV column. Comma, value. Oh wait, I'm doing this wrong. This is how good at this I am. No, the name, oops, sorry. The name of the DV. So this one here, okay, so this is all of your IVs. All of your non-changing variables. This is the data set name. Let me try again. I was about to do this wrong. This is the column of the labels for your DV, right? So this is going to be the factored out column. So in this case, that's time. So it's the factor one. These will change into new columns. And then we've got value equals, and it's the actual DV column. So I got success score here. This is the one that has the numbers in it. So I got the labels column and then the numbers column. And then the last thing you have is a close parentheses, which happened to be way down here, but I'm trying to keep it all together here. So cut that out. Okay. I did a terrible job explaining this here, but here's an example of what it should look like if I hadn't changed the names of the columns. So let's try it with my new fancy name change. Hopefully that'll work. And if I do a summary of that, now I've gone back to the previous data set. So my wide cricket data set and my cricket data set are the exact same thing because I went from long to wide. I find the coding on cast a little difficult just because it's very different from melt. The order is basically the same, but you do your non-changing variables, the name of the column with all the labels for the DVs, because those will be your new columns, and then the name of the column with all the numbers to convert. If you have multiple DVs that you want to keep in separate columns, you will do this a couple times and then combine them into one data set. So let's say you have the example I had earlier of 25 different time points, but you took 2 scales. Well, clearly you want those to be separate columns because you've got like DV1, DV2, so scale 1 and scale 2. I could convert them into long format twice and then C-bind those together. So combine DV1, DV2 into the same data set. Or I could make separate data sets for each DV. It doesn't really matter. Excuse me. But just with melting and casting, make sure it's in the right format first. If you try to melt a long data set, it won't really work, and vice versa. So what this video covered was factor functions, file choosing functions, and reshape functions, because all of these are important to creating graphs, which will be in the next set of videos using ggplot.